Okay, I think it's starting. It always takes a second. You never know when you're actually live. Okay, we are live. Yeah, yeah. Okay. Well, welcome everyone to September 2025 Meetup, HPC and GPU Boston Meetup Group. It's been quite a long time. Let's see.
A year?
It's been a year.
Has it been
I
a year?
hope not. It's possible. Oh, geez. A lot has happened. I feel like that's kind of what I'm coming into this meeting with is tons has happened. There's probably more that our little group could be doing in this moment. Um, let's see, is that coming through okay?
Yep.
Cool. Well, welcome everyone. Um, Kurt jokingly or seriously called this ultra computing. I think it's pretty appropriate. I had never heard of the ultra computer, but you can find it on Wikipedia. When was it? It was like the 80s, and it was this tiny little parallel computer.
Yep.
Uh,
Yep.
so it was, everything seems big at the time, and then it gets bigger and bigger and bigger. That is a little bit what I'm talking about here. Um,
Well, and it's
so
the next logical extension from supercomputing.
super
Super, ultra, I don't know
ultra.
what's after ultra, yada or something. Yeah.
Zeta, people have been throwing around the Zeta. I think we were
Yeah.
supposed to have Zeta by 2027.
Is that right?
Uh, yeah. According to someone's scaling laws, yes.
Well, we've lost all the Greek roots on the low end. Below nano, there isn't much below, femto and meso, and so they're yeah. Now everything's in angstroms. I know all the new fabs are angstroms. So
Yeah, some of that fab stuff is like marketing speak, right? The 2 nanometers doesn't mean 2 nanometers, and have to have someone give a talk on that. I can't do it justice. Well, so anyway, in the spirit of ultra computing and this moment, um, this is Hyperion, the Titan Hyperion of legend, um, because Meta is starting to name their data centers after these Titans. So this is Hyperion. This is Prometheus, who stole fire from the gods and gave it to humans, and are using that fire to run data centers. I don't know. Um, so yeah, so Meta is throwing around the idea that they're going to build data centers the size of Manhattan. Um, right. So people are talking hundreds of megawatts, gigawatts, multiple gigawatts, 5 gigawatts. I think was thrown around this week. Um, so that's a little bit about where industry is. I thought it'd be interesting to talk a little bit about the scale of GPU computing going back to when this group started, right? So this group started in the early 2010s. I'm going to show some different GPU counts with the super caveat that you should not be measuring by GPU count. That is easy to get lost in some ways. But if you're comparing like for like, um, it can give you a sense of the scale as we've gone through the years. But really, you want to use modern benchmarks, um, something that's reflecting the performance of a real world use case at scale, right? So in an HPC era, or in previous HPC eras, we've been talking about a lot of HPL, high performance LinPack, but the HPL committee has already kind of telegraphed that that's not the best benchmark to use for a real world system. So um, in the AI era, a lot of folks are looking at MLPerf, which has both inference benchmarks and training benchmarks. Um, but once upon a time in HPC, going back to 2013, this was Oak Ridge National Labs Titan. They had almost 19,000 GPUs. So what you're seeing there is each tiny little green square is a GPU. And then they're grouped into blocks of 10 by 10, right? So you get 100 GPUs per block, and that adds all shown up here to almost 19,000. So 2013, 19,000 GPUs. 2018, again, Oak Ridge with Summit had almost 28,000 GPUs. So I'll flip back and forth for a second so you can kind of see um, So it's bigger. It's definitely bigger. Um, Not quite a 2x, but as we got into 2022, so this is now nearly 10 years after Oak Ridge is kind of sorry, 10 years after um, Titan went live. We went from 19,000 to 38,000. So that's kind of the doubling over almost 10 years. And then a couple years later, much later than expected, but it happened, we had Aurora at Argonne with 64,000 GPUs. So this is again, right, 2013 to 2025. Um, Again, with the caveats, I really want to make that point. But here's what it looks like over the years: 2013, 2018, 2022, 2025. So definite growth by GPU count, and obviously capability per GPU varies, which is why I keep caveating this. But it gives you a sense for the scale over a decade growth in HPC. Maybe one more, since I keep throwing out these caveats. Um, you won't you won't see Aurora ever taking a top one spot in the top 500. That's the HPL benchmark, so it's not maybe the best benchmark to use these days. But on HPL, Aurora never reached number one, even though they still have the highest number of GPUs, right? And so that again is why you want a benchmark that means something. Um, so the number one system has fewer GPUs than Aurora, but still gets a higher number on that. But meanwhile, in AI land, this is what Meta had in 2023. 49,000 GPUs. I'm using only public information here, right? What would you call it? Like public and believable. A lot of people throw out a lot of numbers, but these are numbers that I believe to be real. Um, so that's 2023. They're kind of beating or on par with the HPC community. One industry player, kind of for one use case. This was Meta's two Meta training clusters, each at 24,000 some GPUs. You can see it's kind of already a moire. So my apologies. I'll do my best to give you comparisons, but it's hard to see as these go. So 2024. The end of 2024, Meta had 350,000 GPUs in their AI training cluster. And now in 2025, OpenAI is saying they'll have 1 million by the end of the year. So that is 3 years, 2023, 2025, 2023 to 2025. This gives you a sense. I wish that you didn't get the more, but that just the numbers are too big now. So
And
this gives you a sense for.
that's
Go
under
ahead.
a single roof, 1 million GPUs under a single site.
It's hard to tell. That kind of information is not public, so I don't want to say yes or no. There is conversation in the ecosystem about multi-data centers. Um, so it has been stated very clearly that folks have 100,000, maybe a couple 100,000 GPUs in one data center. I don't think anyone has spoken publicly with a number larger than that in a single building.
Wow.
That is certainly what Meta's leadership has telegraphed with the Prometheus and Hyperion and things like that, right? They show a picture of a giant data center the size of a city, with the implication that it could have 1 million GPUs in it.
Unreal.
So with like all of that going on and our meetup group has, been not super busy, I am really curious to ask how people are interested in getting involved, right? And I'm thinking of sending a survey around since we have 700 some members ostensibly in the database. We don't see folks very often. But I'm curious if anyone wants to come off mute and comment on this, but ways that we could get together. I know some folks would really maybe like to have kind of a student focus, right? Like get students more involved in some of this stuff. Um, the current federal administration is not my favorite, to put it lightly, but they have announced an AI challenge for high schoolers, and I've been thinking about, hey, can we get some local community high schoolers even involved in some of these activities? But these are kind of the things that I jotted around about topic areas, and the different kinds of activities we could do. So yeah, if anyone wants to chime in now, please do. But I think I'll send a survey around to get more of a sense of what the community is interested in doing. feel like the moment is now to do interesting things. Would anyone wave me off from what I have on this page?
Well,
Don't do it. Stop.
so Elliot, we had talked about the Massachusetts Mass Tech new AI hub possibly
Yeah.
funding. Yeah, so that sounds like something they'd be interested in is sponsoring meetups and things like that, even if even if they're remote and
Yes.
no pizza
That's
involved.
very much true. I'll show a few things that are already happening for people that want to do something that's already happening. So this is what Kurt was mentioning. Um, So Governor Healy has been investing in our state for AI, and that is an investment in infrastructure. So there's going to be an actual GPU system out at MGHPCC, the Green Data Center. It's super great, but lots of other investment in workforce development and incubation of startup companies and all kinds of stuff. So funding and interest in making this happen from the state's top leadership. So you can go to this link if you want to see what's up with the AI Hub. Mass Tech is a nonprofit kind of quasi public organization that helps the state run a lot of their programs. So this is one of them. It's next week, actually. 100 different events, loosely organized, or maybe say loosely connected. So definitely check out AIweek.Boston. There's a whole bunch of stuff
Okay.
you can
I
check
mean,
out.
I mean, so they're going to announce the probably something.
Could be. It'd be a good week to
Could
announce something.
be, could be.
Yes. But yeah, I think there'd be a lot of things there for people to check out. Code for Boston might also be of interest to folks. Um, so have a look at this. Again, this is Zoom, right? So like Kurt was saying, doesn't have to be in person, can be remote for some of these things. I do feel like it's worth trying out these technologies if you haven't been playing with them much. There's a lot of playing you can do. This is another one. These folks meet every Sunday. Sometimes it's virtual, sometimes it's in person. They're a little more hardcore, right? They're like, you better sign up. If you sign up, you better come. We're going from like 9 a.m. to 6 p.m. So they're serious, but if you're into it, I'd say check it out. And then there's also the AI Blueprint, which is a little more maybe has a different flavor to it. I feel like these folks are maybe a little closer into organizing and networking and building ecosystems, but they also have this activity where they'll do kind of like small doers, small groups of people that are working on stuff. So there's quite a few people that are kind of precipitating activities and trying to get things going. At some of the universities, they're doing similar things, trying to kind of take on civic use cases.
Yeah. On October 21st, we have at Northeastern a joint microwave and NVIDIA AI and computing at Northeastern Day. And so I'm not sure you're familiar with that, Elliot, but you should be.
Dave, you broke up for me. Did everyone else hear that? Or maybe it was just me.
Yeah,
Okay.
I could hear it.
Okay,
I
great.
did. I'm Jared from Microwave, by the way. So I fully support saying that people should go to the Microwave joint event with Northeastern.
Excellent.
There you go. And
Is there a link?
if you weren't able to get in, maybe have it at your own school, because this is the beginning of probably a few very nice meetings between where Microwave is
Yeah.
leading the charge in on-campus engagements.
Yeah,
Very
let us know.
cool.
We'll get Elliot to give us the money for it. No.
Oh, yeah, it's already
I
done
can
in
always
his
ask.
name, so that's good.
You have a link for that, a URL?
Not yet. No, it's coming.
Cool, cool. Well, I know that was kind of fast. That's my way.
You also
That's
have a
what I had.
slide. I don't know if you can share this one of the GPUs that academia has. I think you had that at one point.
Oh, I do. I think I would be more comfortable sending that to people on the side if they want to see it. Um,
Okay.
in general, the top universities have 1,000 GPUs. So there's a couple on the East Coast and West Coast that have on the order of 1,000 GPUs in one university. Not necessarily one institution one institute with one university, but that's kind of the scale, right? Like a couple hundred to 1,000 GPUs. Um, but there's obviously folks that haven't been able to invest in the same way. So I would say the median university might have considerably fewer, just a handful, right? A dozen. maybe less in some cases. So it's tough. It's tough
Depends
to
what you call a
really see it.
GPU. You know,
Uh,
if you count MI50s, you've got a lot
Hey,
of
yeah.
Yep.
What is Northeastern's count? I don't know off the top of my head.
You you supplied it at
Let's
Microwave.
see. I do the math.
Was
Oh boy.
8 times 12. I think that was
Yeah,
96
yeah,
just for that cluster. And then we did 7
Of the
um,
DGXs.
DGX2s.
Yeah.
yeah.
So that
Yeah.
helps to get the count up.
Yeah.
Yeah, for sure.
I was doing my share.
And the MGHPCC never throws anything away, so they might have 1,000 GPUs. If
Oh,
you,
definitely.
Oh yeah, they
Yes.
do. They definitely do.
Oh yeah. Oh yeah.
Yeah.
There's one university in MGHPCC that's yeah into the over 1,000, maybe more than one.
yep.
Yeah. Yeah.
Is it like a MIT or something?
It could be. It could be one of the bigger schools.
Oh,
Again, I want
dear.
to be careful about what people have said publicly. I think they all posted in the open, but
Yeah. Well, I believe, I believe on the SuperCloud site, so there's at least one of the big systems that they get into quite a bit of detail on because they like one of the researchers, Albert Reuter, has this, live spreadsheet where he's putting in a lot of stuff about. I believe it may be just SuperCloud. It's one of the big clusters at MIT, and he's constantly mixing and matching new figures of merit. So flops per watt has been a stalwart.
yeah.
But now he's kind of looking at like tokens per watt and token per second for certain.
Yeah. Yeah.
Now that's a hard, I mean, this is a philosophical question. What is a token?
Oh man. Oh
Compare
yeah.
Claude to, yes, to Gemini so that's a tough comparator.
Yeah, a token is a 3D coordinate. It's a video frame. It's yeah, it's, indeed. Yeah, you got to ground it in something real.
So
Uh,
I don't think there'll be a token 500 anytime soon because they're just too hard to compare systems or, well, frameworks.
yeah. Well, so what MLPerf does is they'll, take a certain version of Llama and then, you train that, or a certain version of Llama in an offline kind of like batch mode doing inference, or an online mode where there's a latency requirement, right? So it's like you submit something of a certain context length and you have to get a response back within a certain latency for it to be considered, like an interactive user working with it. So they
Okay.
they have some good bounds on it, I'd say. Um, yeah, yeah,
Yep.
it's
So that'll be a
developing.
good way. You can bring in some externalities if you do it that way. Yeah, because even on identical systems, sometimes comparing these different LLMs can get kind of tricky. But yeah, I hear what you're saying. MLPerf.
Mhm.
If you want, what else you got on the agenda, Elliot? I have my
I think you.
I was
It's the
originally
only
going to
other.
do a roundup of all of the accelerators that are out there now, and there's
Oh,
if you go to supercomputing this year or certainly last year,
uh-huh.
everybody's got an inner loop accelerator. It's kind of like I remember when ClearSpeed came out, 25 years ago, and everybody was like, this'll if I code to this card and I compile to this card, it'll give me 33% speed ups. And I think that sort of ecosystem is coming back.
Hmm.
Never have. I certainly remember a supercomputing where Spark had product, SGI had product, or should I say Sun, Sun and SGI, and certainly DEC Alpha. And now those days may not come back. The processor business may be locked down. But
Mm-hmm.
Who's that by ARM?
well, so there's going to be a million accelerators out there, and they're all going to be
No,
eventually.
no, you said that the CPU is locked down. So,
Well, to like 4 companies. I don't think we'll ever see another architecture. I mean, another architecture company. Like DEC was defined by a couple of its processors, and I don't think you'll ever see that again. I think they'll come in using somebody else's ISA, and we may see 2 or 3 of those companies, but we're never going to see another startup with its own processor or with its own architecture. I don't think. I mean that kind of the curves are sort of pushing against that right now. Anyway, what I will do, so I'm not going to do Yeah. I will start sharing my slides here. See if it's open. Yeah. And I only have about a half hour as well. We don't have a full, we've got to do something with more speakers, Elliot, to get back up to 2 hours.
Yeah,
2 hours
yeah,
and
indeed.
pizza. That used to be our goal, 2 hours and pizza.
In person is good. Maybe 2 hours on virtual is no good. I don't know.
All right.
And
I will share.
if I drop off, please forgive me. I do have to do something tonight.
Oh,
No
sure.
worries.
Okay, so what I was going to do was, especially since
Oh
I put
yeah.
a typo on the homepage, I was going to talk about the proliferation of HPC processor designs, if not products. And I've got some caveats on that later on. But certainly the proliferation of ASICs and FPGAs with accelerators of some variety. So as you know, there's a ton of companies out there that are saying we have an AI accelerator. And what they're usually talking about is some sort of a math accelerator for some portion of the stack. And there's a company called Positron in California. They demonstrated, did you see their booth, Elliot? They demonstrated a halfway decent product demo at supercomputing last year. They'll be back.
I think I missed it. What's the elevator pitch?
So the elevator pitch is they have an A/B test. They have a server which was running Llama and was doing so they gave a bunch of prompts and it was doing some thinking, and then they did the exact same demo with their cards to accelerate. So it's some sort of so I think it's a glorified cache. Like maybe it's so you run the prompt, you get some data back after a couple of seconds, you run it again, you get it back much quicker. And some variation on the prompt too. And this isn't unique to Llama, I guess, but Llama is what everyone's using for demos. So
Yeah,
they'll
yeah, makes sense.
and this company was started by one of our local. There's a lot of people that started at Massachusetts schools and either graduated or didn't graduate and then moved to California and get into one of the startup communities there. And this certainly fits that description. We also had a bunch of Harvard students who were probably a semester away from graduation and quit because Peter Thiel said, "I'll give you some money if you quit college and start and do a startup."
Hmm.
So they have. I'll pull up their webpage too. So they have an AI accelerator. Now they're very vague on their product. I think they have a model,
Hmm.
not much more, and some modeling and simulation. I don't think they have a product. They certainly don't have a production run. They may have
Yeah,
a
okay. Okay.
prototype or two. So I am not doing HPC processors. What I am doing is talking about a new memory model and a new memory paradigm and why, as if we didn't need more access and better access to memory before, we really need it now, is because um, all of these data centers that we're going to be logging into now, the 1,300 acres in Wyoming, perhaps, we will want to maximize our prompts so that we're not burning any tokens that we don't have to. I saw some wild descriptions on the price between a bunch of very highly tailored prompts and how much that cost you to get valid data back, and something very similar, which was 10 times as expensive because prompt engineering was so important to craft well, you can substantially fix a lot of that if your target cluster, your target HPC data center has memory management down. Now, the way we manage memory at SuperCloud is by telling people to request more cores to get more memory. Now, that's the system RAM. Every server, very predictable amount of system RAM in there. In fact, and you tell me the way you guys did it at Microwave, if this is wrong or not. People would say, why don't you fully populate the system bus so that I can get maximum bandwidth to memory? And I'll just take, the cheaper DIMMs, they're like, instead of 512 gigabytes, they're 128 or something like that, but fully populate it so that I can have maximum bandwidth to memory. And then about a year from then, you say, well, geez, I'd really like to upgrade my memory on this server. And your options are basically yank out 4 DIMMs or 8 DIMMs or something like that, throw them away and stick in the next, the next model up. So you go from 128 gigabyte DIMMs to 256. So that's how we did memory upgrades up to and including yesterday. Well, here's how we're going to do it starting. Oh, I'll go back to this page. Here's how we're going to do it starting tomorrow. And it's with taking advantage of Compute Express lanes. Now, this slide doesn't tell the entire story. I think what CXL was originally developed for was people were saying, a lot of this stuff is very similar, conceptually. We've got memory measured in bytes, and sometimes we're using it, as non-volatile storage, but it's all bytes. Can't we have something that might be able to do double duty? Like, maybe somebody will actually design a DIMM that will have some non-volatile memory on it, and of course, Micron and Intel did exactly that. And it wasn't that there wasn't a market for that product. It's just that I don't think they could ever get any sort of reasonable price point. So both Micron and Intel ended up, getting rid of the Optane product. So a lot of people sat back and said, you know what, they were maybe onto something here. Why don't we talk about replacing a lot of these I/O calls, which are awkward. It's much easier to use, malloc and memcopy and things like that in our code. Why don't we just figure the vast majority of our hot data is going to stay in memory, and we'll only have to do I/O very rarely, more rarely than we do now, which is to say that instead of doing backup and restore on any sort of scheduled basis, we just do a lot of checkpoint and restart. So now we get to rebuild our servers, get rid of a ton of SSD and hard drive and all of that. I mean, unless your contract and grant specifies that you have to do scheduled backups and tape and things like that, and say, if I have a crash, I will have 30 seconds to do a snapshot and I'll do a checkpoint restart, and instead of a backup. So now we don't have these massive PDUs at the base of the 44U rack. We have something much lightweight, and you only get about 30 seconds in a complete power outage. But that's the route they want to go. So a lot of these slides, I just saw there's a lot of people selling CXL products right now. I think Liquid has some of the best ones, and I've got permission from them to use a lot of their generic slides. Some of these slides are from last year, but now these products are in the wild. You can buy quite a few of these products. What they're pitching is a composable model where you buy 5 of these outboard one-stop system style chassis that are full of CXL memory, and then on the lower half so that's a 42U rack. They've got 5 servers and 5 CXL chassis. Now, you can mix and match those. There was a really great Serve the Home YouTube video a couple of years ago where he compared CXL to tacos and how you could mix and match, the different kinds of tacos. And I'm sorry, it's vintage. I'll put a link to it at the end. So those bottom 5 blocks in this cartoon are CXL chassis, and the top 5 are your servers, which is to say that if you've got a server that you've been using for a while and it's tuned for your application and it's got the right accelerators in it, then you probably don't want to mess with that too much. However, all of these apps, every one of them, all 1,500 on the NVIDIA accelerated application database could benefit from more memory. Now, there's a lot to take advantage of CXL. You either have to buy a CXL chassis with a CXL switch in it and talk to that, or you can buy one of these products from any of the big VARs and ISVs. So Supermicro has CXL PCIe 5.0, CXL 2.0 certified equipment. You can buy from Supermicro, you can buy from Dell. I would assume Microwave has products. Everybody has CXL 2.0 rated equipment now. The tricky bit is how you get exactly the mix of products you want. So go out and find somebody that sells a CXL 2.0 capable PCIe 5.0 card. That's not everybody. I don't believe it's NVIDIA yet. However, the promise is you'll be able to use all the RAM on that card if it's CXL rated. And you'll be able to access it from these combination composable modular network options that companies like Liquid will offer you. There's a bunch of other options here. The one that Liquid is proposing, they call it software-defined composable infrastructure, because they would to maximize your throughput, they really want you to go through their orchestration server. And I have a picture of that coming right here. That thing right in the middle, you see that Liquid director? So if you've got your 160 PCIe lanes from your AMD-based server, and you've got them all committed, you've got probably 5 of these 16 of these X16 lanes coming out of the back. You can hook them in directly to your individual servers. So if I'm in a, let's say I'm in a shared data center that 5 universities have clusters there. So my Wharf simulator wants a ton of RAM. Your Quantum Espresso simulator wants a ton of RAM. Somebody's Redis database model. So we're all working. We've been working on these data sets for a while. They could all benefit from more RAM, but more importantly, they could benefit from just seeing more RAM, more proc mem info. This doesn't require revisiting the source code and recompiling. It's any user, any non-program person could use it just by running it. And I think the way I would take full advantage of it, to harken back to the document guidelines at SuperCloud, is I would take advantage of all of the options in Slurm. So you can do mem per core in Zoom, in Slurm. You can do task per core. There's a lot of directives you can pass. And indeed, if anybody's going to set one of these up and allow multiple PIs and postdocs and grad students to get into it, it will almost certainly be managed through through a queuing system. Probably Slurm. That seems to be, and correct me if I'm wrong, either Jared or Elliot, I haven't found a university yet who has not pivoted to Slurm as the RC, queuing system of choice.
Yeah, Slurm is extremely popular, especially in the EDU space. I have seen people doing Kubernetes though.
Really?
Yeah.
Doing okay.
Yeah.
Anybody using any legacy stuff? I don't know, Condor or
PBS every once in a while comes up.
wow.
Yeah. Somebody was like, "Oh, we still pay for this." I'm like, "Okay."
Yeah. Some schools, yeah, they want to maximize, they want to amortize their investment, yeah, over like 10 years. So this Liquid chassis has 10 slots in it, 10 full PCI slots. There, you can certainly buy CXL cards from Smart Modular that are double wide. So that would eat up, so you only get half as many slots if you do it that way. However, in fact, I think that might be the Smart Modular card. Yeah, that's the 8F2 wide. So you put 8 DIMMs in that. The alternative is they also have a card that's the 4F1W, 1 wide, and that has 4 slots, and they rather than 8. So I think most people would probably opt for the 1 wide card, because here again, if you fully populate all your PCI slots, you're going to be getting maximum bandwidth to your RAM that way. And I think that's going to be the selection of choice. There's not a whole lot of these in the field. You'll be able to go to supercomputing, and the servers will have a nice piece of plexiglass over it, and you'll see how some people have arranged their CXL configuration. Now, CXL memory is, I believe, that's the big use of CXL. I know of a couple of other CXL capable cards, but I'm not really sure how you would pool those, or maybe what that would be is that would be more of a one-stop system model where you just have 16 slots full of some kind of an accelerator, and it all just shows up as if it was one big PCI root complex. Now, I don't know if that's true for the particular manager that Liquid uses. I have not seen a demo of this. So this little schematic here, this shows you how you would take 5 of their chassis and plug 5 servers into it to maximize the use of all of your PCI lanes. Now, I don't know how this would work with I don't see that the director is in this schematic. This is all direct connected. And I could show you the back of their chassis. It has 5. The reason they call it 5 by 5 by 16. So these are all on an AMD system, you get more PCI lanes than on an Intel system. So they're using 5 of those for every server. And then I guess they're counting 5 servers with 5 of these optical connectors that are coming out of the back. And I'll show you what that looks like. Yeah. So the way they're marketing this is the value proposition here is if your app is a memory hungry app and it scales, it just keeps scaling no matter how much RAM you put in, you're probably building on a system that has a fully populated system RAM bus. So you've done that. The only person that can use that is the person using that server, even if it's on a shared system like SuperCloud or something like that. Your code is running on that in a queuing system. It absorbs all of the available RAM. What they propose to the academic and the research computing communities, if you're going to do that, why don't you all pool? Say you've got 5 of these servers, put all of that RAM conceptually into one CXL chassis, and then all of you can use all 10 terabytes for a fifth of the time. You will benefit dramatically from that configuration. This is the pitch. I think I'm going to look through NVIDIA's 1,500 codes to find out what the poster child to prove that is. Because right now, if you log into one of these systems at one of these R1 universities, getting a ton of cores doesn't seem to be a problem. Getting a ton of CPU cores and to a lesser extent, a ton of GPU cores. And then even, pinning a gigabyte per thread or process or something like that, that doesn't seem to be too much of a problem either. We'll have to find a code that greatly benefits from excess memory. Well, not excess memory, but from just opening up. There's a option in Slurm to do max mem per thread. So this is another one of their slides. Here again, I don't think, other than the memory products, they're saying there will be CXL rated storage accelerator and networking products that will plug into the PCI bus. And more interestingly, they say by about the time of the 616 kernel, there'll be a lot of CXL things that you can compile into the kernel. FAMFS, which is a CXL file system, hot plugging. So I don't want to be the first guy to have a running CXL server up and yank a CXL card out of the chassis, but PCI hot plug, that could make for some interesting designs. They have already built in some of that functionality into Slurm. Right now, if you did do a warm configuration change, I don't think there'd be a hot configuration change. But if 5 of you were using your servers with 5 shared chassis, and all of a sudden it was user 2's time to take over the entirety of the memory space, you would effectively have to do a reboot right now. A lot of this functionality is in the BIOS, well, not the BIOS, but the there is a reason you need to reboot. Maybe it's just that they need to reassess all of the cards on the PCI bus. What's the term for that? Not retime, enunciate.
Remapping?
Well, it's
Enumerate.
no,
Oh,
re-enumerate.
yeah.
Yeah.
Now, I guess you can't do that hot or warm. I think you have to reboot your server for that, unless so maybe this problem goes away at the 6.16 kernel. Um, but uh, but that's also pretty encouraging. I mean, if that seems to be of all the things you can knock on CXL. Oh yeah, so I was going to show a video here, but I don't know if you've been noticed on YouTube lately. There's a lot more commercials than there used to be. So I ended up not being able to put I a free frame on the commercial though. So but that's kind of my CXL overview. And what's good about that overview, uh, uh, despite all of its shortcomings, is these products are shipping. You can log into Supermicro has a jumpstart program that you can request an account and you can SSH into a CXL based server of your the choice of your processor and test out some CXL um, experiments. I don't think the interesting experiments, in my opinion, are to overload one of these servers with 5.5 terabytes of CXL memory, which is what you can get if you fully populate it with either the smart modular cards or the Micron cards. And Gigabyte, I don't know if you saw that announcement from Tom's Hardware a week ago. Gigabyte is selling a low end CXL memory card for workstations. If you're not in the server business, this is going to be something that you'll be able to use if you're a gamer or something like that. I haven't investigated that yet. I don't think the product's actually really shipping, but that's really encouraging what you're going to be able to do with crazy memory swaths. I think 5.5 terabytes is going to be more of a basement than a ceiling here pretty soon. You fully populate your system bus and use that however you want. Maybe that's where your hot data is if you're a database guy, or you can use it some sort of memory tier, an additional cache level or something like that. I think it's a good time to be alive right now.
Huh.
May you
That
live
is,
in interesting times. We've come
yeah.
full circle of
So you talked about Optane before. What are these new memory devices like the gigabyte memory device? Are you sacrificing latency? Is that the main sacrifice?
So yes, and comparing apples to apples, we can get, and I think I do have a slide on this. I'll post this to. Actually, I could probably look up that slide right now. It's kind of a wash for bandwidth. You configure your cards right, you're going to be competitive with system bus bandwidth. Now, where they win on latency, you can claw back, considering that you're not going to flush cache very often and have to reload. So before, certain applications, you would speculate out 8 deep or something like that and say, okay, well, I'm just going to have to live with the fact that I'm going to have to flush the cache every now and then. And now you can probably say, well, I've got this little system cache thing that I've stuck into a terabyte of my CXL memory. And you may have to mess around a bit and see how deep and how wide you have to speculate for that to be valuable. But I know not having to flush and reload your cache is probably going to win the latency argument. And that's one of the things we want to demonstrate is doing something with as much system RAM as we can now, and then basically doing something with double that amount of RAM with only half of it being system RAM. And I think maybe I'm not really sure what code that's going to be. That may be a benchmark.
Hmm.
ML-perf. I don't know, Elliot. I got to get smart on ML-perf.
Yeah. I want to ask the audience, does anybody know what's the memory hungriest code that's out there? Open question.
Yeah. It'd be interesting if we find something that just grabs everything that's there. Because, like I say, we can do all sorts of allocation management and pinning and all that in either the source code or the Slurm config. But it would also be interesting to see if there was some sort of an app out there that would just grab all the available RAM. You turn off everything else, turn off interrupts and everything, and just just see what you get. I have looked around for a CXL memory um, benchmark suite, and I have not found one. I think the guy at Open Benchmarking, Phoronix, is kind of interested in
Oh
this.
yeah, yeah, yeah. Okay.
But we haven't had, like the team around here who has been trying to investigate either how to do, if the overhead of manually managing hot and cold and warm is worth the price, or if just having some sort of statistical thing to move your hot memory around. They've been working in the modeling and the simulation and the CXL QEMU world for a long time, and it's very hard to really get a sense of what's available in that world. So they're very, very stoked that we might be able to get remote access to a CXL server. We did try the startup, the Jumpstart program at Supermicro, and that worked out pretty well, but they were not going to populate the PCI bus for us. So we only really got to try out some of the mechanisms. We didn't get to do any testing.
Hmm. Hmm. The network card swapping is interesting to me too, because I never think of needing to add and remove network devices midstream.
Yeah. And it may not be in the middle of your code. It might be that your code is finishing up and we're queuing up somebody else's code.
Sure, sure. Yeah.
And at that point, if you are really pivoting to a new user, I don't imagine a cold reboot is all that much of a problem. Although hard reboots are kind of hard to manage remotely, right? Don't you have to have like IP addressable plug strips and things like that? And
That's pretty doable these days. I would say that's a solved problem. I mean, my sense is that um, people are willing to reboot. They're willing to reboot between jobs. It's more like, can it be automated? And what is the timing, right? If it's a 5 minute reboot once a week versus 5 minute reboot every hour or something, right? How much time are you losing?
yeah, yeah. Trying to think how much of that they do. So SuperCloud, unlike a lot of universities, they have a hard system-wide reboot, a 24-hour outage once a month. So you
Hmm,
can't,
hmm.
yeah, you can't run a 5-week job on SuperCloud. Now, there are some jobs that need 5 weeks or a month to run. So they have a special accommodation for some really unusual runs. But in the old days, there weren't a whole lot of really unusual runs. Now, most runs are really unusual. When you get one of these data sets from case,
Well,
163, billion tokens, and it's like, all right, I don't know if we can leave this on the swap over it certainly won't be there after the reboot. So, yeah, I'll have to check with some of the other universities and find out how they deal with those mega heavy projects. You know,
yeah.
spring break, they have certainly spring break around here. There's a bunch of jobs queued up that they've worked out some sort of special lockout deal with the sysadmins. And uh,
Hmm.
of course, the NeurIPS conference. So there's a conference every year. I believe it's in New Orleans, and it's always the same time. And they always have a non-negotiable deadline. They should have a rolling deadline. So you get a spectacular amount of contention, the week before the
Yep.
NeurIPS
Yep.
publication deadline.
NeurIPS, iClear. I feel this is a couple now.
Yeah.
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 Boy, oh boy.
All right. Well, I'm going to work on. So next time we get together, I'll have a proper HPC processor discussion. I think it's not like the good old days are coming back. We'll never have SGI thinking machines, Cortex. So, it won't be 50 computer companies out there, but there might be 12 computer companies, five of which will have some variation on the same design. Yeah, yeah, they'll significantly up our computer company count.
Yeah, keep it interesting. Yeah.
So I had a question for you, Kurt. That Supermicro system you were talking about for CXL,
Yeah.
do you know what it was?
Yes. So they had something called they've got a bunch of the Supermicro uses this naming convention H14, and I think
Yep.
yeah, so H14 is the Intel based one, right? So
AMD.
oh, that's the AMD based one.
Yeah.
Okay, so they had two SKUs under that program, and they
Hmm.
were both CXL 2.0. That's like the first thing they had on the spec sheet was like PCIe 5.0, CXL 2.0. I can find out exactly what the SKUs on those were.
Yeah, that would be interesting because, sometimes I can get access to stuff and, might be able to provide people, free experience on it. So,
Well, cool. Yeah.
yeah.
And we should talk. I was kind of surprised at how, you go to a place like Dell and they only have a couple of SKUs that support CXL 2.0. And I
Mhm.
thought for sure, there's a lot of products that are kind of being dialed back. And correct me if I'm wrong, I don't think they offer a 3D V-cache version of the latest EPYC 5 processor. Have they started dialed back the X? Like, is there a Genoa X or a Bergamo X or anything? Um,
I don't recall offhand. I don't think so.
'Cause I thought that was one of the really big novel things that AMD did was the Milan X and so that's too bad
Um,
because
9684 Genoa X.
oh, there is one.
Yes.
Okay, so that's good.
Yeah.
That's good. But that's for those of you that don't know the nomenclature, they solder bumped a huge level 3 cache on the top of the non. So they've got an X version with a bunch of SKUs, and then they've got one without an X. And the X means that they put 3/4 of a gigabyte of level 3 cache on top of that existing product line. And I thought that was brilliant. There's a lot of very cache hungry codes out there that benefited from that. So I hope they keep that product line going. I think I said 3/4 of a gigabyte, 3/4 of a megabyte. No, yeah.
I have to look it up. Yeah, I
Yeah.
know the orders of magnitude. They're getting larger.
Oh, I know. Now that we're talking about terabytes of RAM, I was like, wait, what? What? Like you say, the Greek roots are all shot,
Uh,
it's like we're running out of things at the top end and the low end. Yeah.
Jeepers.
All right. Well, next time we'll do
Oh
this
man,
at Microsoft Nerd, Elliot.
that'd be fun.
They owe us.
Yeah, yeah, indeed.
Okay.
Yeah, maybe November. I'd be up for a post SC pre or post, but have more to talk about after. Yeah,
Okay.
yeah. Well, cool. Thanks, everybody. Hello, anyone watching after the fact. Hope it was useful. All right. Well, have a good evening, everybody.
Yeah.
You too.
Thanks.